Hi everyone, this lesson continue from limit. Okay, so this today lesson is the removable discontinuity. Actually, this one is continue, say from still in the exercise 14.4, and this lesson, this exercise 14.4 really is important because this one we can say is a conclusion of everything from the beginning you learn and you practice the question from exercise 14.1 up to here. Now 14.4 at this lesson is a conclusion, can say that. So everything in one question is from beginning until now. But this one only increase one more question is removable discontinuity. Okay, so today we will learn when is the removable or not removable yet, not removable discontinuity functions. So, but before that, of course, is related from previous lesson continuity, correct? So I will refer a little bit how we find out this function is continuous or discontinuous. Okay, so just remember the three steps, like this one, right? If we want to find out this function is continuous or discontinuous, have three steps, right? One, you have to find out, say, the question give to us, find by the function of c is divided or not. Like the last time, you see, I explained, give you example for this one, correct? If you remember, otherwise you have to go back to see your handout or in GC I explain this one, right? So the first step, if say question give this function equal to this one on the right hand side. So how you do the first one, for the first step, you replace x equal to c, correct? So and this one they give us say x is equal to -3. They want to question us, they continue us or discontinue us at x equal to -3. The first step, you replace x equal to c. That means you replace everything like this one, -3 inside. Okay, I want to finish that, but you replace it in, that's it, right? For the first step. And then for the second step, you have to find limit. Then limit exists or not exist. Right now, x equal to c, right? No plus minus sign on the right corner, remember? So this one means it's a two-sided limit, right? So you have to, for the second step, you have to find limit f of x, right? When x equal to c negative, and limit f of x when x equal to c positive. That means to the left hand and right hand, right? So if you find out this one, if you find out the answer, this one equal to the first step. If they're equal, that means it's the first step, right? This is the second step. And then purple one's the first step. If you can find out 1 equal to 2, if you find out 1 equal to 2, that means the value of limit. This one, if you find out, and equal to the number f of c here, then you say this is a continuous, right? This function is continuous. Or even, and again, this one limit number 2 here, the second step should be existed, right? So, and have to be equal to the first one, then you can say this is a continuous, this function continuous. But this one we work already is continuous. Okay, but another way is if limit, even though exists, but if the number, when you find out the number to the step 1, if there is not equal, then this one is a discontinuous. You know why? Even you plot graph, right? When even though, for example, this approach, this one they say -3 should be this side. Assume if you have this one x at the same point, right? Maybe this graph like this. Remember the homework you used to work on. At x equal to -3, right? For example, this one say this one open back dot. Okay, but this y is a one number. For example, this one may be 2 and this one may be 1. So then you see even they happen at the x equal to -3, same, but the value of y they come up different. So even though in this case you have to say discontinuous, okay, even though the limit of function exists, like in this case, and even though the f of c at the first step, they don't happen, they exist here, but the value of y different. So then this one discontinuous. But this example we work out already is a continuous because both of them 1 and 2 equal. From the third step, we can prove this one they're equal. They're equal, is equal, okay? So then this one just review from last time. When we consider that the function is a continuous or discontinuous. But again, once you have this thing happen, in the same question, I can ask you continue add in the same question about this function is removable discontinuity or not, or this removable discontinuity. So that's we're gonna learn. Then you see the example, the definition of removable discontinuity here on the brown color here at the top. Means a function f, right? The function f that is not defined at equal to c is said to have a removable discontinuity at equal to c. If there is a function g such that g of c is defined, g is continuous at x equal to c, and function g of x equal to function f of x for x not equal to c. What the meaning in this one, I will give the example better, and then I will point it out what is a g and what is the equal to c, and when equal not to c something, and f of x, like this one, this f means function f of x. Okay, f of x means the original function the question give to us. Okay, now g of x is the function can simplify. Okay, then we talk about see example like the way I will give you next one example. Now this one. This I will get from the exercise 14.4 of the question 9, because this one the will explain everything in about the function is continuous or discontinuous, and we can find out the removable discontinuity also at the same time. Okay, so I will get, so that's why I get this question, this one to be the example, because they can explain most of them. I write down, so this one should be at the middle. Okay, now we start from this one. For this question, I want you to find this function is this continuous or continuous, and also find the removable discontinuity function also, where the answer. Okay, so now we start to work. Do the same way that at the beginning you learn. Find for the continuity, first one, right? First step we have to find what f of c exists or not, correct? Right, f of c, right? So then you just see, you replace this one because they give us the continue or discontinue at x equal to 2 from the question. So you say if f of c when c equal to 2, or that means x equal to 2, then you replace x in there. Okay, so this is the first step. You replace in there. So what we have become 2 become 4, right? Minus 9 over, and then this one gonna be 4 minus 2 minus 6. Okay, and then also this one become 2 become 4 plus 12 plus 9. So what we have the whole thing. So negative 5 on the top, and the bottom is what? 8, so become minus 4, right? And this one 12, 12, 16, 16, 16, another 9 become 25. Okay, then you find out what we can have, because minus become plus, so 5 divided by 4, and then divided by 25, 50. So we have approximate, or almost, I think maybe exact 0.05. So we have 0.05. Okay, this is a first step. We can find function of c when x equal to c, which is x equal to 2. That's replace. The first step, remember. Then now we try to find continuous, not continuous, correct? Use the same way. The second step, we have to find limit. Okay, step. we want to find limit f of x when x approaches to f of x mean this one, right? F of x mean this one, the whole thing. So then before I want to find this one, I have to check first, correct? The first step, we have to check first if we replace see there come out with 0 over 0 or infinity over infinity or not, right? But in some question we can, if see this one is kind of, we can simplify. So you go ahead, simplify, don't need to check this one. Because, okay, so several times, sometimes you have to consider each question when. But in this case, it seems we can simplify, correct? We can simplify f of x. So before that, I simplify first. I will write this one. I simplify f of x, so we can factor it, right? Factor this one. Become x minus 3, x plus 3. And then over the bottom one, we can factor or not? I think we did, we can, right? So factor it. Now we do this one, okay? So this one, okay? So x and 3, 2 minus plus, yes, we can factor. And this also, this one can factor, right? So become this one, x, 3, 3, right? And then both of them plus, then we get middle term. Yes, so we can simplify. After we can simplify, you say, can we remove, I mean, cancel, you always say cut, remember? So we can cut, correct? This and this and this and this, correct? So we left what? We left this one become, the top one become 1 over x plus 2, x plus 3, right? A1. So this one we left this one, this and this, x plus 2 times x plus 3. Okay, then you see this after you one we can simplify and we can simplify to lower term, right? So in right now we concerned about the removable now. So we get the new one, the blue color here, 1 over x plus 2 times x plus 3. We name this one as a new function. We just say like a g of x. From the definition beginning, I left for you that one. So we'll give this one as a g of x. Okay, but from that before we're gonna go removable, we find first this function is a continuous or discontinuous. We go to the second step, still continue. Okay, continue. So from the second step, when we have this one, we take limit both sides, correct? We take limit. Then we can, because we want to check the say we want to check, say the limit of this function is exists does not exist. Okay, so we have to do like this, limit f of x when x approach to 2, right? Then we have to find out, say, when we can simplify, we can say we want to prove limit f of x, but we still use f of x. Okay, this one we don't use g of x yet. Okay, so we write limit f of x when x approach to 2 plus equal to limit. We do two sides of limit, you remember? To the left. Okay, but this one we want to see there equal doesn't exist or not doesn't exist, right? We don't know yet. We like question mark on. Now we continue this one, but because one we have, we simplify equal to this one already, correct? The blue one. So I like the blue color here. So I have from this one, after this one, you can replace, because f of x is what? Maybe I like that here. Limit f of x, we like this one, 1 over x plus 2 and x plus 3 when x approach to 2 plus, that's right. So we have 1 over 2x plus 3, this one. This is x plus 3, okay? After this, because we simplify already, we can replace x equal to, we can replace x equal to 2 right away, right? From the question here, okay? So then when you replace x in there, limit lighting disappear. So we have 2 plus 2. This is a step if you show the work, okay? And then you can work separately, up to you, okay? But now I just like this way, step the page, this one 2, okay? 2 plus 3. So that means this one equal, right? Both of them become 20. This one also. 4 times 5, 20, yes. Approximate 1 over 20 is about what? What, 0.05, right? So same. See that? So this one, they are same, right? So you see this one. So we can find out now the step 1, step 2 equal. So we can say like the way step 3, f of c equal to limit f of x when x approach to 2, and this one c is equal to x equal to 2. So then you can say like the way this function is continuous. Okay, so this we find the first one. Now, second question I will ask you, does this function have any removable discontinuity? Okay. Then after this one, I'm gonna ask you plot graph also. Okay, right now remember, right now this one, after simplify, right? After simplify, I will assign this one as equal to g of x. That will go to the definition of removable continuity. Okay, so when this one, when you can cancel it, right? When you can cancel it, that means you can simplify and cancel it. The left function with new name is a g of x. Okay, now this we go next one, how to find the removable discontinuity. Okay, in the same one, same question now, same question here. Okay, next one. Now we have to plot graph. Okay, this one, this the one we just work on, right? The same question. This is a question 9. Okay, this is a question 9. This one, question 9, we just finished from the one. So this one we simplify here, right? You got g of x here. So then only this one, g of x. Okay, plot graph g of x. So from g of x, how we get vertical asymptote and horizontal asymptote? How to get vertical asymptote? Vertical asymptote is the bottom one here, right? X equal to -2 and x equal to -3, right? If they equal, then become undefined. So this is a vertical asymptote, remember? So then you write the vocal line here. X equal to -2 right here, like the vocal line. And then x plus 3, that means vertical asymptote, x equal to -3. So you write the vocal line here, right? When you have vocal line here, then have vertical asymptote, you can find horizontal asymptote of g of x, right? Is what? Y equal to 0. Even remember, because the top is the x power 0, right? And the bottom x is higher. So then y is equal to 0. That's a horizontal asymptote. Then why I like the vocal line on the x-axis, the orange one here. So in this function g of x here, function g of x, we plot graph and we find vertical asymptote and horizontal asymptote first. Okay, so vertical asymptote and horizontal asymptote. So we got this one, right? Then you plot graph, go according you used to learn last year. When you plot graph this one, right? For you replace x from the right hand side, from the right hand side here, from the right hand side here, right? From the right hand side here, you can plot graph. You can replace any x, right, to this here. For example, you say x equal to from the right hand side here. So you say if x equal to 1, you replace 1 there, and then you will get y. Okay, and you keep doing. And at the same time, you have to find y-intercept and x-intercept, correct? But this case, no x-intercept for sure, because if x-intercept, y have to be 0, that means g of x to be 0, right? So 0 times this one, the whole thing, undefined. So that's why we got horizontal asymptote y equal to 0 here, the broken orange color. And vertical asymptote, we got it x equal to -2 and -3 here. So this is a vertical asymptote. The blue color here, the broken line here, okay? So that's the one vertical asymptote. Once you have this one, you just plot graph, right? And then this one we can find y-intercept, x becomes 0. This one you say if y-intercept, right? X becomes 0, correct? So you replace x equal to 0 here, then you will get equal to 1/6, correct? So that's a y-intercept. So that's why I have it here. I load it down here, y-intercept become 1/6. So this graph, when you replace x one at a time, right, from the right hand side, you will get about this shape. And then this graph will approach to the asymptote x equal to -2 and approach to the x-axis. That is the approach to x-axis here. Okay, that's a graph. And after that, you plot another graph between -3 and 2 here, -2 and -3. So you will get a little open down of the parabola. The vertex is a -2.5 and the y is about -4 here. Everyone gets? So this one, I let you plot by yourself, okay? You just replace x at that one at a time in g of x here. Plot this graph only, okay? Not f of x. So on the left hand side, do at the same time. You replace, for example, you say x equal to -4, and then you replace in here, x -25, you put in here in g of x, right? And then you will get this graph. Everyone get? So this is how you plot graph, plot from the function g of x after you simplify already. Okay, after you simplify. Okay, so but one point I want to tell you, because right now I have the open dot here, open dot, or some another word we call void, open dot, void, okay, void, void, open dot. Then you like open dot, why? Because come back to the pink one here, open dot, come back to the f of x here function. Okay, because when you eliminate, you cut, remember the beginning when we do the question, you cut x -3, x -3, and x +3, x +3. When you cut them, you remove already. So when you plot graph, the graph, even though you plot from the g of x, the graph will pass to 3, right? This side. Just say any graph, if they pass through this one, x equal to 3 and -3. You must like open dot, like this one I plot it down. Why? Because this remove already, because you cancel it. You cancel this one, and this one. So that you already cancel when x equal to 3, right? This one 3, okay? X equal to 3, that means this one, this point. And x equal to -3 means this one. This 2 point, the value of x already remove it. So we call this one is a removable discontinuity. Okay? So we call this, after you cancel or cut, we call this one is a removable discontinuity at x equal to 3 and x equal to -3. Everyone get? Okay. And I think that's all from the podcast. Now you can see what I loaded down here. F of x, you see this. F of x means this one, by from the original equation, f of x has a removable discontinuity at x equal to 3 or -3. That's the one I just explained here. Okay. The simplified equation. That means after you factor and you cut, simplify, right? You got the new one become g of x now. This one g of x. Okay. This one g of x. After you simplify, mean this one now. Everyone get? Has a discontinuity function that is not removable at x equal to -2 and -3. What the meaning here? You see the bottom here. This one, correct? That means x gonna be -2 and x equal to -3. That one is a vertical asymptote, right? It's a vertical asymptote, means this one x equal to -2 and -3 here become vertical asymptote, which is actually this one has not removable yet. So we're still there, but we have to represent as a vertical asymptote. Okay, but the f of x, some part we remove already. It mean the one you already cut it. You cut it out to simplify. Just say that like this one, the blue color I cut. When they pass the graph, they say the graph will pass through this point. Then we open dot it. So that's called open dot. And this one, sometimes we call void. Remember this word, please. And that means this one mean is a removable. Removable discontinuous. Discontinuity mean this one here. A1. This one mean this one here, okay? The pink one here. This one come here. Everyone get? So, but there the graph and your plot, they will pass to these 2 points. If pass these 2 points, you must write open dot. But x equal to -3, they do pass or not? No, because x equal to -3 exactly is a vertical asymptote. It's already open dot anyway, but we represent as the asymptote line because the graph can pass through, right? But approaches closer to x equal to -3. But this one, from this one, x equal to 3, the graph pass through, but become discontinuous. Because did you see from here, you have to jump, let your pen up, jump to the other side. Everyone get it now? So everything you learn beginning is everything in here now. Exercise 14.4. They include everything in here. So that can explain everything at the beginning. How you find limit, exit or doesn't exit. How to get the function is a continuous or discontinuous. How to find the graph is a removable or not removable. Right now you understand removable is means that when you simplify and you cut, get it out, that's a removable. You learn from long time from elementary level, from the grade 9, grade 10. You know how to simplify, right? Cut it out. Actually, the meaning is right here. Everyone get it now? So please see this one again, second time, third time. Okay, if not, we talk to you in the Zoom meeting and one more time. Okay, so but you see this one first. So everything is in here. So when you do, no matter you do any questions, they can answer you all. Okay, this is a really important exercise. You need to practice. I will let you question to practice. Okay, for 14.4, talk about limit, exist or doesn't exist, continuous or discontinuous, removable or has not removable, at what point, that is the one. And how to plot graph. Actually, you can plot graph this one, f of x and g of x, but now I don't want you to do f of x too much work, right? Then you do only this one, g of x. This one can answer for f of x also. So you plot graph at the last one after you simplify. You plot graph after you simplify the function of that one. Okay, and then we left one more, 14.5, and that's all. 14.5 very short, is the infinity, and that's it. And then we can finish limit. Okay, so please watch one more time. I will leave it right here. And then you practice question. If not, we work together, okay, in the Zoom meeting if we have more time to do. Okay, I think I will leave it right here. That's all for this lesson. See you next class. Bye-bye.